Right. Ready? So, good morning, all of you. The summary of the last lecture, we have discussed this Compton effect. So, what is this photoelectric effect or Compton effect? What is the main aim? What is the purpose of these two experiments? The purpose of these two experiments to show that light is having particle nature. Light is having wave nature, you know already. You studied interference, something. Okay. So, actually, reflection, refraction, diffraction, and interference. So, I think you know Newton's corpuscular theory. Just we will go a little bit outside and we will talk. Reflection and refraction is there. Okay. Now, your student asks you, sir, reflection, refraction, we are treating as a light as a wave and we are explaining. Incident ray, reflected ray, refracted ray. A student asks you, light is behaving like a particle, na? How we will explain reflection and refraction if light is a particle? Question understand? You will easily explain reflection, refraction by using a light as a wave. So, this is the incident ray, this is the reflected ray. So, angles are same, something like that we will explain. Brevister's angle, everything will explain by using the, what is that one more critical angle. All these things will explain by using a light as a wave. If you ask a question, you are saying now light as a particle. How you will explain reflection?
It is very small that the size of the distance between the size of particle.
First listen the question carefully and give the answer relative to that only.
When it strikes the boundary and it will act as a particle,
Huh.
and when it is deflected, it acts as a wave.
No. Particle is coming, particle is going. But angle remains same. Why angle remains same? There is no loss. There is no loss means what? It is a elastic collision. Then you have to explain to him. This is a particle-particle collision. From the photoelectric effect, what we understood? Light behaves like a particle, and the particle is coming and striking with the electron. That is a particle-particle interaction, that too elastic collision. Refraction. Refraction, generally what you will study, if it is moving towards the denser medium, bend towards, if it is moving in the denser medium, it bend towards the normal. Rarer medium, it bends away from the normal. So what you have to explain? For example, if you have a denser medium, the denser medium particles are having a nature of attraction. So whenever it is having a nature of attraction, the ray, whatever it is going, it bend. If it is having a repulsion nature, so that means what? It will go away. It's a small, if anybody asks. So because now we are saying a light as a particle, immediately they will ask. So how we will explain that reflection and refraction? Reflection is a elastic collision. Refraction means what will happen? Denser medium particles are having the nature of attraction. Rarer medium particles are having the nature of repulsion. That's why that light ray bend away, repulsion. And this is attraction, that's why two words. Good, ready. Okay, now take a fresh page and put the heading. De Broglie dual nature of matter. De Broglie dual nature of matter. Right. So till now we have discussed about light. So first time we are introducing this matter. Actually, there was one a mathematician, Mary Noether. She was the lady mathematician. Okay, lady mathematician of the era. Era ante? Our whole generations. Okay, right. That was a great lady mathematician, Mary Noether. So she made a statement. Nature loves symmetry. Whenever anything is happening in the nature, always it aims towards the symmetry. Okay. So Okay, that was the statement given by Mary Noether. Now de Broglie was the student of Heisenberg, was a research scholar under Heisenberg. Heisenberg was the student of Rutherford. He is again scholar under Rutherford. All are Germans. Okay. So de Broglie, what de Broglie thought? If you see the nature, what you are observing in this classroom? Fans, benches, human beings, light. Other than this, anything else? Space is not here. If space is there, we can't stay here. We'll fly. Atmosphere. Anything else? No. Either matter or radiation. If you see something in the nature and if you ask what is that? Either matter or radiation. So this entire nature consists of two things. One is the matter, another is radiation. That's why always matter will be converted to radiation, radiation will be converted to matter. Pair production, pair annihilation. Pair production means matter. A photon converted to electron and positron. Pair annihilation. A particle and antiparticle combine and you will get a radiation. That is called pair annihilation. Something like that. Okay. So what de Broglie thought? This entire nature is made up of light, radiation and matter. Already people decided, from photoelectric effect, Compton effect, everybody decided light is having dual nature. Both wave nature it is having as well as particle nature. Then de Broglie thought, if nature loves symmetry, nature contains only two things, particle and radiation, matter and radiation. Radiation is already having dual nature. Then why don't this matter is having dual nature? This was the idea he got from the statement of nature loves symmetry. Let us start with the beautiful word. Nature loves symmetry. Good. So this nature consists of only two things. One is radiation, another is matter. But remember, in this universe or in this nature, always this is the conversion, radiation to matter, matter to radiation. So example I will tell you, maybe if you forget. So there is a gamma, sir, photon of minimum energy 1.02 MeV. Sir, what is the minimum energy? If you have a photon of minimum energy 1.02 MeV, then only you will get an electron and a positron. The minimum amount of energy required for the pair production. So this is called pair production. Pair. Because common sense, what is the rest mass energy of electron? 0.51. What is the rest mass energy of positron? 0.51. Particle antiparticle mass remains the same. That's why this is the minimum energy. Is that clear? Second one. Sometimes what will happen? Electron and a positron, something like this. And what you will get here? 2 gamma. What you will get? 2 gamma. So this is called pair annihilation. Pair annihilation. That's it. So some people will ask, why this 2 is there? Here you have not written, sir. Why you have written 2? Don't say, that's it. Adante raskone aladdu. Ikkada 2 ledu. Ikkada 2 undi. Why? Adi gamma na, idi gamma na. That is also gamma, this is also gamma. But one place you have not taken 2, but here you have taken 2. Why? What is the reason? Conservation of momentum. Conservation of momentum. Actually, I will tell you. If this is the particle coming, now you got the two particles here. So such that the resultant momentum of these two, okay, is balanced with this. But here what happened? Two particles are coming, but here resultant is what? If 2 is not there, 1 particle. That is not possible. Okay, so if 2 particles are coming means one is from the positive direction, another is from the negative direction. So net momentum, let us say 0. But here you have only 1 particle, that's why net momentum won't be 0. So here also 2 must be. So the 2 is because of conservation of linear momentum. This is very important question in particle physics. That's good, fine. So it contains only radiation and matter. These are the reactions occur in the nature, okay. Now the point is radiation, that means light, it is already having a dual nature, because we know the two theories, the wave theory, that is Huygens wave theory, Huygens wave theory, Newton corpuscular theory, but actually photoelectric effect and Compton effect confirmed the particle behavior of light. Is that clear? Good. Or else I will write like this. From interference and diffraction, from these two you can confirm which nature? Wave nature. From these two you can confirm which nature? Particle nature. Clear? That's it. So, and what de Broglie got the idea of de Broglie. See, I don't want to say simply statement. De Broglie idea. So I think now you got it. Nature loves symmetry. Nature contains only these two things. This is already having dual nature. Then matter also should have dual nature. Why? Nature loves symmetry na. You confirmed nature loves symmetry. So these are the only two things. One thing is satisfying means another thing also must be satisfied. Otherwise, symmetry does not exist. So this was the idea. Matter should also have dual nature. That's good. So that is both the particle nature as well as wave nature. Amma, this is your question. Whatever I said question, please put a star mark. That is your question. So matter is also having dual nature. Which experiment confirmed wave nature of the particle? That's the question. Which of the following experiment confirm the wave nature of the matter? Davison and Germer experiment. Davison and Germer experiment. And one more, G.P. Thomson. Who is G.P. Thomson? J.J. Thomson got Nobel Prize. G.P. Thomson got Nobel Prize. Okay. Particle behavior of matter. Counters. So that's it. So this was the basic idea he got. So and after that, of course, in 1927 or 28, I think he got the Nobel Prize also for this. So finally, come to the conclusion. Babu, is there any not understanding any point here? Please tell me. స్టూడెంట్కి ఎవరైనా ఉన్నారయ్యా? పే చేస్తే పంపించు. ఇప్పుడు వెళ్ళి తీసుకురమ్మన్నయ్యా. ఏంటి మరి చిన్నపిల్లలా చేస్తారు. రెడీ సార్. ఇదా అండి? ఇది వన్ మోర్ టైం. అవునండి. 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 కూర్చోండి. ఇది ఎలక్ట్రాను, ఇది అనదర్ పార్టికల్. ఈ పార్టికల్ ఎలక్ట్రాను, దిస్ పార్టికల్ బోత్ ఆర్ డిఫరెంట్. దిస్ ఈజ్ అ పాజిట్రాన్. ఫర్ ఎవ్రీ పార్టికల్ దేర్ ఎగ్జిస్ట్ అన్ antimatter. For example, if you see the particle physics, there will be lot of particles will explain. There we will explain. Okay, for every particle there exists an antiparticle. Antiparticle property, all quantum numbers are same. Which quantum numbers are same? Intrinsic quantum numbers are same. And remaining charge, spin, all these things will be opposite. That's why mass remains same, but charge is opposite. Okay, so charge is opposite. So intrinsic quantum numbers, that's why charge is opposite, but mass remains same. That we will describe in the very clearly in the particle physics, no need to worry. So this is the electron and this is the positron andi. Mass same untadi, but charge is also charge is different. We will discuss there, not now. Next, shall we proceed? Conservation of linear momentum means, for example, if there is a collision, sir, A plus B equal to C. If I say linear momentum is conserved in this equation, then what is the meaning of that? Momentum of A plus momentum of B equal to momentum of C. Initial momentum is equal to final momentum. Now what I am saying is, particle and antiparticle, actually according to the Feynman diagrams, they travel in the opposite time directions. According to Feynman diagrams, let us say particle and antiparticle are coming like this. Now opposite directions. So what is the total momentum, sir? Zero. Vector P minus P. Answer 0. After collision, you are having only one particle. So how this momentum is 0? Photon momentum is not 0. So that's why what they are saying is, there must be another photon. So this is the collision, this is the photon. So that means the electron is coming like this, for example, and the electron is coming, positron is coming like this. After collision, such that their momentum, resultant momentum is 0. That is the meaning of that. Okay, right. Now ready. So very important, please listen. De Broglie statement. One more time I am saying, this is your question. Which of the following experiment confirms the particle nature, wave nature of the matter? Davison and Germer, G.P. Thomson. Davison and Germer, diffraction experiment. Right. De Broglie statement. What is this? Now for example, according to De Broglie, this is what? Matter. If I throw the matter like this, then definitely it must be associated with a wave called matter wave. So don't ask me, sir, you are moving na, where is the matter wave? I am moving na, I am a matter, so I am moving. Where is my matter wave? You can't see. Why? It's a travel with the speed of light, greater than speed of light. If anything greater than speed of light, do you have any significance? No. That's the point. In 1 minute. Here is a particle of mass m is moving with a velocity, okay, and then it is associated with a wave called matter wave. Cool. A particle in motion, a material particle in motion is associated with a wave called matter wave, and whose lambda, wavelength, lambda equal to h by p. That's good. So that lambda equal to h by p, which can be written as h by mv, where v is the velocity of the particle, and lambda is the wavelength of what? Matter wave. Okay, now you got a doubt. The particles are moving, buses are moving, cars are moving. Where is their matter wave? Let us see. Sir, if you want to find the velocity of any wave, what you will do? Sorry, statement is clear? Once again say, a material particle in motion is associated with a wave called matter wave, whose wavelength lambda equal to h by p. Good. Sir, I want to find velocity of matter wave. Velocity of matter wave is what? Frequency into lambda. Say yes or no? Velocity of any wave is what? Frequency into lambda. Okay. Master, according to Max Planck, energy equal to what? Nu equal to what? Virend, please listen. I am taking this and substituting master. E by h, master lambda, h by mv. E gets, sorry, HH gets, sir, energy is nothing but what? According to Einstein theory, E equal to mc square. That's good. So, mc square into 1 by mv. Mm gets, that is, oh, velocity of matter wave is very much greater than c. That's why you can't see. I want to ask a question. This is the matter, right? Piece of chalk. If I throw this with a velocity of light c, what will happen to this? A, disappear. B, melt. C, as it is. D, we can't say.
Disappear.
If this particle throw with a velocity of light c, I got powers, okay? Yesterday God given powers to me. I can throw this with a velocity of light c. What will happen to this matter? A, disappear. B, melt. C, as it is. D, I don't know. Disappear. Velocity of light తో వెళ్తుంది. Then what will happen to this? కనిపించదు. ఎందుకు కనిపించదు?
అంత స్పీడ్ లో మనం చూసలేం కాబట్టి.
ఏదో something is happening there. Whenever any particle is moving with the velocity of light c, it will be converted into radiation. I told you already, only two interactions in the nature. One is matter to radiation, radiation to matter. If anybody asks what happened to radiation, converted to mass. If anybody asks what happened to matter, convert to radiation. Other than this, no reaction. You know hydrogen bomb, atomic bomb, all these things. What is that formula? What is the formula? I am asking formula given by Einstein. E equal to mc square. What he said is, if you take some mass and if you burn it or something like that, you are getting some energy. Am I right? So the same thing, matter converted to energy, radiation, whatever it is. Okay, anyhow, that's it. So velocity of matter wave is greater than c. That's why no physical significance. No physical significance. Anything travel with a velocity which is greater than c is not having any significance. That's why the matter wave is not having significance. Is that clear? Then what is a matter wave? It's neither electromagnetic wave, it's not an electromagnetic wave, and it's not a mechanical wave. That we will discuss. First write down. I'll give the time. Please, while I'm explaining, listen the points carefully. Because I can't right now, I'm throwing a particle, moving, all these things I can't. But once you listen properly, you will understand. Ma, please be here by 5:30. Okay, don't be late, please. Today, because of this Physicse, it was late.
Broglie statement is applicable for every particle.
Every particle. I will give the statement. First write down, after that finally I will give the statement.
Sir, you telling we have radiation and matter only, no? The sound wave, all these are also there.
ఏంటండి?
Radiation ఇంకా matter ఉందన్నారు కదా. Sound waves ఇవన్నీ.
సౌండ్ ఈజ్ ఆల్సో ఎనర్జీ కదా, ఫార్మ్ ఆఫ్ ఎనర్జీ.
రేడియేషన్ కాదు.
మీరు చూడరు కదా, మీరు చూస్తున్నారా సౌండ్ వేవ్ని? చెప్పండి. నేను అంది ఏమి కనపడుతుంది అని అడిగాను, మీరు నేచర్లో ఏం చూస్తున్నారు అని అడిగాను. Sir, voice is clear? If anybody is having issue, please raise the hand. Voice, please increase your system sound. From our side, there is no issue. Padmaja Chilikuri, there is no issue from our side. CH Ravi Garu, while I am explaining, don't write. Okay, now see, after the explanation, simply you are sitting. After the explanation, you have to write from the board. ఇది ఒక బ్యాడ్ హ్యాబిట్ అండి. వైల్ ఎక్స్ప్లెనేషన్ ఈస్ గోయింగ్ ఆన్, యూ షుడ్ నాట్ రైట్. లిజన్ వాట్ టీచర్ ఈస్ సేయింగ్, ప్లీజ్ లిజన్. Right. Okay. So this was the statement which inspired de Broglie, that is, a nature loves symmetry. From that statement only he got the idea, that is why this matter should not have this dual nature. So then he started, and of course finally he got the Nobel Prize also. Don't think for this is simple they got the Nobel Prize. No, lot of things are there behind this. A lot of so much mathematics, so many things are there. Velocity of matter wave, there is no significance of matter wave. The reason is velocity of matter wave is very much greater than c. Sir, if two photons are moving in the same direction, what is the relative velocity? C only. Opposite direction, what is the relative velocity? C only. Nothing is greater than c. Remember this. క్యాన్సిల్ అవుట్ కాదు, యాడ్ అవుతాయి. మీకు రెండు బస్సులు ఆపోజిట్ డైరెక్షన్లో వెళ్తున్నాయి అనుకోండి, ఆ బస్సులో ఉన్న అతను ఏమనుకుంటాడు, అబ్బా చూడు ఆ బస్సు చూడు ఎంత స్పీడ్ వెళ్తుందో అనుకుంటారు. అంతే కదా, ట్రైన్స్ ఆపోజిట్ డైరెక్షన్లో వెళ్తున్నప్పుడు ఏముంటుంది, మీరు ఒక ట్రైన్లో ఉండారు, మీ ఫ్రెండ్ ఇంకో ట్రైన్లో ఉన్నారు. ఆపోజిట్ డైరెక్షన్ వెళ్తున్నప్పుడు ఏమనిపిస్తుంది? అదేంది ఆ ట్రైన్ అంత స్పీడ్గా వెళ్తుంది అనుకుంటారు. యాక్చువల్గా రిలేటివ్ వెలాసిటీ VA మైనస్ VB, దట్ ఈస్ VA ప్లస్ VB. అది 40 kmph, ఇది 40 kmph వెళ్తుంది అనుకోండి. ఇన్ వన్ ట్రైన్ ద పర్సన్ ఫీల్ అదర్ ట్రైన్ ఈజ్ మూవింగ్ విత్ 80 kmph. But in case of photons, it is not like that. Ready? Right now, statement. A material particle in motion is associated with a wave, called matter wave, whose wavelength lambda equal to h by p. Next one. Matter wave is not having white pages notebook lo rayali please. Matter wave is not having any physical significance. Any physical significance since its velocity is very much greater than c. Next point. Matter wave is neither EM wave, electromagnetic wave. Tell me why it is not EM wave? If it is EM wave, it must travel with c, but it is not traveling with c, it is traveling with more than c. That's why it is not a EM wave. Neither EM wave in bracket velocity is greater than c, and you will understand later, nor mechanical wave. What is a mechanical wave? What wave it is? Mechanical wave, because you are doing some mechanical work and then wave is produced. That's why it is called a mechanical wave. So why it is not a mechanical wave? Sound wave needs something, medium, but matter wave can travel in the space also. That's why matter wave is not a mechanical wave. Neither EM wave nor mechanical wave in bracket without medium, and without medium also it is going. Without medium, and mechanical wave ante without medium kaadu, matter wave without medium. Okay, confuse avuddu akkada. Okay, అంటే మీకు అర్థం కావడం చెప్తున్నాను. వై ఇట్ ఈజ్ నాట్ మెకానికల్? వితౌట్ మీడియం ఆల్సో ఇట్ ట్రాన్స్మిట్. వితౌట్ మీడియం ఆల్సో ఇన్ బ్రాకెట్ వితౌట్ మీడియం ఆల్సో ఇట్ ట్రాన్స్మిట్. రైట్. నౌ లిజన్ మాస్టర్, ఆల్ ఆఫ్ యూ. యా, So if a material particle thrown like this, that is moving with the velocity, then it is associated with a wave called matter wave, whose wavelength lambda equal to h by p. Good. Am I ready? Right. Listen. So here you have used one word, material particle. First of all, what is the particle in quantum mechanics? You are studying quantum mechanics only, na? Right. What is a particle? How many particles are there? Whenever you are going to 1D box or harmonic oscillator, these words continuously it will come. Free particle, bound particle, relativistic, non-relativistic. So first let me introduce those things. Are you ready? Right. Now particle classification. Amma, listen, very important. First listen please, don't write. Classification. Okay. So first classification based on potential energy. Based on potential energy. Now see, for example, whenever there is a particle of mass m is moving, for example, I have taken a 1D box, 1D infinite box, this is of infinite height, and here is a particle. If you observe carefully, what particle I have taken? Free particle. Why I said free particle, you know? The potential energy is 0. Oh, wherever the potential energy is 0, that particle is called? That's it. First one, free particle. What is the meaning of free particle? Potential energy. 0. Good. Then the total energy is always kinetic energy plus potential energy. That's why potential energy is already 0, p square by 2m. That's it. So this is the total energy of. That's good. Next listen. Now for example, this is a finite well. Finite well. It's not infinite, it's a finite. Now this is having a potential depth minus v, or if the particle is moving in a barrier, then this height is v. Okay. Now the particle is going, or particle is here, or the particle is here. So in this case there is no potential energy, but in this case we have potential energy. Is it negative potential, attractive, and this is the positive potential. Okay. Ready? Yeah? Now in this case the potential energy is not equal to 0. Then the particle is said to be bound. Oh, based on the potential energy, two types of particles will be there. Free particle, bound particle. Whenever in your question they said free particle, then immediately you have to take potential energy 0. There exists only one energy, kinetic energy. So whenever they said bound particle, potential energy is also there. Is that clear? Now see. Okay, could you please tell me what is the energy here? E square by 2m minus v. And if you take here energy equal to p square by 2m plus v. Okay, right. So don't forget, something like this. Fine, anyhow. And second classification based on velocity. Very important, because if you don't know this terminology, you will face trouble. Based on velocity. Okay. Now for example, I am a particle, I am a body, physical body. Now I am moving with some velocity. That means I have some kinetic energy. Now I am at rest. I have some rest energy. Earlier kinetic energy and now rest energy. Now tell me, I am a relativistic particle or non-relativistic particle? Relativistic ante not relative. అదే మీకు చెప్తున్నా, అదే మీరు టర్మినాలజీయే నేర్చుకోవాలి. ఫస్ట్ ఒక 15 days ఇలానే ఉంటుంది మీకు. అంటే టెస్టింగ్ పీరియడ్ అనమాట. 15 డేస్లో మీరు నిలబడగారంటే సబ్జెక్ట్ వస్తుంది, లేదంటే పారిపోవాల్సి వస్తుంది. ఇక కొంచెం ఆ ఇనీషియల్ స్టేజ్లోనే కష్టంగా ఉంటుంది. అంటే ఏంటి డిఫరెన్స్ ఏంటి అంటే ఇంగ్లీష్లో చెప్తున్నారు కదా, వీఆర్ మాకు తెలుగు వర్డ్స్ తెలియవు, సబ్జెక్ట్ తెలుగు వర్డ్స్ తెలియదు, అది అందుకని ఇంగ్లీష్లో చెప్తున్నారు కాబట్టి కొంచెం అలవాటు చేసుకోండి ప్లీజ్. నౌ ఐఎమ్ మూవింగ్ విత్ కైనెటిక్ ఎనర్జీ. రిమెంబర్, I never travel with a kinetic energy or move with a kinetic energy which is greater than my rest energy. My rest energy is what? mc square. My kinetic energy half mv square. That half mv square never be greater than rest energy. Such type of particle is called non-relativistic. Wait a minute. Okay, so here is a particle of mass m which is moving and it is definitely have kinetic energy. I think everybody know what is its kinetic energy, half mv square, and definitely it is having some rest energy. E naught is equal to mc square. If you assume m naught, this is also m naught. What I am saying is kinetic energy of the particle never be greater, that means what? Less than rest mass energy. Such type of particle is called non-relativistic. If I say an electron, this is the point, and in the question you will get this, an electron of kinetic energy 0.3 MeV. Either relativistic or non-relativistic? Non-relativistic. Why? Electron rest energy what? 0.5 MeV. Now what is the kinetic energy? 0.3 is less than 0.51. That's why, is it a relativistic or non-relativistic? That's good. Now I hope everybody understand this. Next one. Sir, same particle m naught is moving with the velocity v. It is having some kinetic energy and of course rest energy which is m naught c square. Now see here, kinetic energy is very much greater than rest energy. So very much. Sir, how you will give this very much high energy cyclotron? If you take an electron, you know, large hadron collider, LHC. What is this, a large hadron collider? They have taken 2 protons. Okay, these 2 protons are traveled in a cyclotron. Okay, after so many rotations. I hope you know, in BS you studied. So for every rotation its velocity is keep on increasing. So it almost reaches the c, velocity of light c. Then they made collide. That is called a hadron collider. Proton is a hadron. So once they collide with each other, that is equivalent to big explosion of supernova. Actually, supernova was exploded. What happened, nobody knows at that first moment. The speculation is there was some particle called God particle, Higgs boson, God particle. The people are calling that. But what is that particle, whether it exists or not, that is confirmed by this large hadron collider. So how the protons got that much velocity means because of this cyclotron. We will use cyclotron and we will give the velocity. Is that clear? Good. Some people ask, na, how you will kinetic energy, sir? You will throw it? No. Particles will keep it in the cyclotron. Ready? Kinetic energy is very much greater than rest energy. Then this particle is called relativistic. Don't write, Babu. Online students, listen. Relativistic. Okay, sir, example. Cool. In the problem, consider an electron is having kinetic energy, an electron of kinetic energy 1 MeV. Kinetic energy of electron 1 MeV. మీరు ఆన్సర్ చేస్తూ ఉంటే ఇక్కడ ఉంటారు, ఆన్సర్ చేయకపోతే ఎక్కడో ఉంటారు. ఇది ఎవ్రీ 15 minutesకి ఒకసారి వెళ్ళిపోతుంది బయటికి. ఎందుకంటే ఎవ్రీ 14 మినిట్స్కి బ్రెయిన్ చేంజ్ అవుతూ ఉంటుంది. అర్థం కాల? ఎవ్రీ 14 మినిట్స్కి ఇది యాక్టివ్ లెఫ్ట్ టు రైట్ టు లెఫ్ట్ యాక్టివ్నెస్ చేంజ్ అవుతూ ఉంటుంది. అలాగే మీరు కూడా చేంజ్ అవుతూ ఉంటారు. అది ఎప్పుడు మీరు క్లాస్లో ఉండాలి అనుకుంటే మీరు ఆన్సర్ చేస్తూ ఉంటే మీరు ఇక్కడ ఉంటారు. లేదంటే కోచింగ్ రాకపోతే ఇంటి దగ్గర నిద్రపోతూ ఉండేవాళ్ళం చక్కగా శుభ్రంగా. ఇదేందో పార్టికల్ అంటాడు, రిలేటివిస్టిక్ అంటాడు, నాన్ రిలేటివిస్టిక్ అంటాడు. చూడండి, కైనెటిక్ ఎనర్జీ ఆఫ్ ఎలక్ట్రాన్ హౌ మచ్? 1 MeV. రెస్ట్ మాస్ ఎనర్జీ ఆఫ్ ఎలక్ట్రాన్ ఈజ్ హౌ మచ్? యా, E0 of electron is 0.51 MeV. Sir, kinetic energy is very much greater than. That's it. That's why relativistic or non-relativistic. That's good. So I hope everybody understand what is the difference between particle classification. Free particle, potential energy. Zero. Bound particle, potential energy. Next one. Particle, non-relativistic. Relativistic. Right. Come on. Write down. Sir, online students also, please try to give the answers. Otherwise, you won't remember. Shall I ask a question?
Relativistic kinetic energy is very much greater than rest mass energy. For that statement, can you give one general example? Because I didn't get it.
Which one, sir?
Kinetic energy is very much greater than rest mass energy.
Relativistic particle. We can't see. In our daily life, we can't see. Okay, that is the special theory of relativity. Special theory of relativity observation, nothing we can't see. Only, that's why I said, if you keep it in the cyclotron, then only you will get that. Otherwise, no.
So what is rest mass energy?
Whenever you are at rest, that energy is called rest mass energy. If the mass is at rest, how much energy? mc square. That is the rest mass energy.
Telling well and bound means what?
Amma, we will explain. First today only concentrate on those 2 points. Potential well will come, potential barrier will come. After showing the equation, it will come. అంటే వెల్ అంటే నెగిటివ్ పొటెన్షియల్, దట్ బ్యారియర్ అంటే పాజిటివ్ పొటెన్షియల్ ఉంటుంది. దీన్ని అట్రాక్టివ్ పొటెన్షియల్ అంటారు, దాన్ని రెపల్సివ్ పొటెన్షియల్ అంటారు.
అంటే ఇన్ జనరల్గా అది రియల్గా ఎట్లా కనిపిస్తుంది?
రియల్గా ఎలా కనిపిస్తుంది అంటారా? మీరు ట్రాన్సిస్టర్ తెలుసా మీకు? డయోడ్ తెలుసు కదా? ఎలక్ట్రాన్ ఈ పీ టెర్మినల్ నుంచి ఎన్ టెర్మినల్కి వెళ్ళాలంటే ఎంత పొటెన్షియల్ ఇస్తే వెళ్తుంది? పిఎన్ జంక్షన్ డయోడ్ సిలికాన్ డోప్డ్ అయితే. ఒక డయోడ్ ఉంది, సిలికాన్ డోప్డ్ ఉంది, పీ టెర్మినల్ అదే ఈ టెర్మినల్ నుంచి ఇంకో టెర్మినల్కి ఎలక్ట్రాన్ ట్రావెల్ చేయాలంటే ఎంత పొటెన్షియల్ ఇస్తేనే వెళ్తుంది? 0.7. ఆ బ్యారియర్ అనేది 0.7. అసలు ఆ 0.7 ఏంటో తెలుసా? బ్యారియర్ పొటెన్షియల్ అంటాడు. అంటే ద మినిమం పొటెన్షియల్ రిక్వైర్డ్ టు క్రాస్ ద జంక్షన్, పిఎన్ జంక్షన్. ఆ జంక్షన్లో ఏముంటుంది అంటే పొటెన్షియల్ బ్యారియర్ ఉంటుంది, దాన్ని మనం బ్యారియర్ అంటాం. ఆ ఎలక్ట్రాన్ ఆ బ్యారియర్ నుంచి క్రాస్ చేయాలి అంటే మనం మినిమం పొటెన్షియల్ ఇవ్వాలి, అది బ్యారియర్ అంటే. Quantum mechanics is not the things which we see. మా మీరు సీరియస్గా ఉంటేనే రండి దయచేసి. మళ్ళీ ఇంకోసారి చెప్తున్నాను సార్, మీరు సీరియస్గా ఉంటేనే రండి మా దగ్గరికి దయచేసి ప్లీజ్. మళ్ళీ నేను ఏమన్నా మిమ్మల్ని అంటే మీరు ఫీల్ అవుతారు, ప్లీజ్. ఎందుకంటారు సార్ అంటే నాకు నచ్చదు, అందరిలాగా బ్లైండ్గా టీచ్ చేయటం నాకు నచ్చదు. బీ సీరియస్ అంతే, అదర్వైజ్ డోంట్ కమ్. లేట్గా రావద్దండి, 2-3 డేస్ చెప్తాం, తర్వాత అసలు అలౌ చెయ్యం. ఒక మూవీ థియేటర్కి వెళ్తాం, 200 టికెట్ పెట్టుకుంటామండి. ఎన్ని గంటల ముందు వెళ్తాం? మినిమం హాఫ్ అన్ అవర్ ముందు వెళ్తామండి. ఎందుకో తెలుసా? 200 రూపీస్ టికెట్. ఇక్కడ మీరు 25,000 టికెట్. ఎందుకు దొరకరు, ఉంటారు, చాలామంది ఉంటారు, కానీ మేము కొంచెం ఓవర్ అంతే. చాలామంది ఉంటారు. మాకు ఐఐటీలో ఫస్ట్ నేర్పేది ఏంటో తెలుసా? ఫస్ట్ నేర్చుకునేది బ్రేక్ఫాస్ట్ దగ్గర టైం సెన్స్. 7:30కి బ్రేక్ఫాస్ట్ క్లోజ్ అవుతుంది. నువ్వు 7:31కి వెళ్ళి 100 టైమ్స్ రిక్వెస్ట్ చేసినా అలో చేయడు. అంతే. 1 మినిట్ లేదు, 2 మినిట్స్ లేదు, గెట్ అవుట్ అంతే. అంటే అప్పుడు, ఇప్పుడు ఎలా ఉందో తెలియదు నాకు, ఐ డోంట్. అక్కడే వచ్చేస్తుంది టైం సెన్స్ అనేది. రెడీ? ఓకే ఓకే. Because everybody know about non-relativistic, we want to discuss about this relativistic. How you learn mother tongue? How you learn mother tongue? What is your mother tongue? I didn't ask. How you learn mother tongue? Listening and speaking. The same way physics also, if you want to learn, speak out, speak out. Don't feel that you know everything. No. Once you are speaking, then only you will know whether I know or not. Right. Ready? So this is the classification of the particle. Am I ready? Online. Right. So free particle and a bound particle, non-relativistic and relativistic. Now here we want to discuss more about this relativistic particle because we have to discuss the de Broglie wavelength. That's why first let me discuss this. Okay. Now this is the rest mass m0, which is moving with the velocity v nearly equal to c. Then according to special theory of relativity, Einstein's theory, whenever a rest mass m0 is moving with a high speed, then its momentum will be increased. Momentum increased means mass increases, velocity not increasing. Velocity already you have given. Okay, what is increasing? Mass is increasing. Generally in the textbooks, momentum will be increased anted. Momentum increased means velocity increasing, mass increasing, and mass increasing. Because velocity you have already given, 0.7c, 0.8c, 0.9c given. Clear, sir? Right. So momentum increased means its mass become gamma times m0. What is the dynamic mass? Shall I say this as the dynamic mass? Dynamic mass. That means the mass whenever it is moving. This is what mass and rest mass. Moving mass is how many times? Wait. What is the gamma? 1 by under root 1 minus v square by c square. Wait. Gamma value. That means they have given velocity and you have to find a gamma. Okay, 1 minute. Babu, if you don't know, try to remember. Don't get tension. Gamma value 1 by under root 1 minus v square by c square. Earlier you don't know, today you learn, go and practice. That's it. Now, Sir, once again take m equal to gamma m naught. Sir, multiply with c square. mc square equal to gamma. What is mc square? That's it. Okay. For a relativistic particle, what is the relation between mass and rest mass? M equal to gamma times m naught. Energy equal to gamma times rest energy. Okay? Wait. Here focus. Because this is a small, very, very important question for you. They will give velocity and they will ask mass become how many times or energy become how many times. And if they have given velocity, what you have to find? Gamma. Sometimes gamma they will give and you have to find a velocity. Generally what students will do, I will tell you. Generally, this is one most important application. Listen please, application. Sometimes velocity is given. They will ask mass or energy. If you want to find mass or energy, what do you want? Gamma. That means you have to find gamma. Sir, I have given velocity v equal to 3 by 5c. What you will do? You will take this and substitute here. Am I right? Everybody will do this, sir. In the state, everybody will do this only. Because we will take the velocity and substitute. How much, sir? 3 square by 5 square. 9 by 25. 25 minus 9, 16. 16 by 25. 5 by 4. Gamma equal to 5 by 4. This is generally everybody will do this. If you have cross multiplication, they will struck. What I am saying, I will tell a small technique. Please remember, within seconds you will get the answer. Don't forget, please listen. Sir, gamma value is always greater than 1. Why? Just now I said, mass increased or decreased? Increased means gamma must be greater than 1. Okay. Sir, ఒక పైథాగరస్ థీరం ఐడియా ఉండాలి మీకు. రైట్ యాంగిల్ ట్రయాంగిల్. ఈ రైట్ యాంగిల్ ట్రయాంగిల్లో విచ్ సైడ్ ఈజ్ మోర్? హైపోటెన్యూస్. ఓకే. నౌ సీ. Gamma, sorry, what is given? Velocity given. What is asking? Wait, listen, I will tell you. Sir, one more thing. Gamma is always greater than 1 and velocity is always less than c. ఇది మర్చిపోవద్దు. Velocity is always less than c. ఎందుకు సార్? Why sir? Put v equal to c? 0. Something by 0? Infinity means? Undefined. Infinity అంటే ఏదో వాల్యూ అనుకునేరు. It's undefined. We can't define. So that's why, listen. Master, velocity given అండి. నేను ముందు రివర్స్ తీసుకుంటే బెటర్, మీకు అర్థమవుతుంది. 1 minute. Okay. So, gamma equal to some a by b is given andi. A by b. He is asking velocity. ఇక్కడ మీరు కొంచెం కన్ఫ్యూజ్ అవుతారు. గామా వాల్యూ సబ్స్టిట్యూట్ చేస్తారు, స్క్వేరింగ్ ఆన్ బోత్ సైడ్స్ చేస్తారు, వెలాసిటీ ఫైండ్ అవుట్ చేస్తారు. ఇది ఏమీ చేయకుండా పైథాగరస్ థీరం తీసుకోండి. రెడీయా? గామా ఈజ్ గ్రేటర్ దాన్ 1. సార్, గ్రేటర్ దాన్ 1 అంటే ఈ న్యూమరేటర్ హైపోటెన్యూస్ అయి ఉండొచ్చా, సైడ్ అయి ఉండొచ్చా? హైపోటెన్యూస్. ఈ బి అనేది ఏదో ఒక సైడ్ అయి ఉండాలి కదా. రైట్. ఇప్పుడు మీ థర్డ్ సైడ్ కనుక్కోగలరా మీరు? ఎస్. √a² మైనస్ b². నేనేం చెప్తానంటే, గామా ఈజ్ ఆల్వేస్ ఈక్వల్ టు హైపోటెన్యూస్ బై సైడ్ 1. ఎనీ సైడ్. అంటే 5/4 given gamma, sir. 5 hypotenuse, 4 any side. Then find the third side, 3. 5, 4, 3. Okay. So then velocity of the particle equal to, this must be less than or greater than? Velocity. Less than c. Less than c means denominator is high, That's why denominator must be. And the numerator is other side. Side 2. Wait. Let me take a small example. Into C. Obvious. Into C. Amma, listen please. Okay, here is an example. Gamma equal to 5 by 3. Now take a right angle triangle. Gamma must be greater than 1. So that's why 5. 3, anything you can take. Here or here, anywhere. 25 minus 9, 16. Root 16. Now, velocity equal to, sir, denominator 5. Now, which side you find? మీరు స్క్వేరింగ్లు మల్టిప్లికేషన్లు ఏం చేయాల్సిన అవసరం లేదు, డైరెక్ట్గా వస్తుంది. మీకు స్టిల్ అర్థం కాకపోతే ఐ విల్ టేక్ వన్ మోర్ ఎగ్జాంపుల్. వెయిట్ డోంట్ రైట్. ప్లీజ్ డోంట్ రైట్. ప్రాక్టీస్ దెన్ ఓన్లీ విల్ రిమెంబర్. మీరందరూ చూస్తే గుర్తుంటుంది అంటారు. నో, చేస్తే గుర్తుంటుంది. ప్రాక్టీస్ చేస్తేనే గుర్తుంటుంది. Right. So one more example. Now this one. Give something else. 13 and 12, let us suppose. Okay. Sir, gamma 13 by 12 is it greater than 1? So come on, say sir, right angle triangle. He is asking velocity without doing any mathematics. Try to say hypotenuse. Other side. And what about this? 169 minus 144, 25. Maybe you will get a doubt how the sir got 5. 13 square minus 12 square, 5. Now velocity equal to denominator. Here. Let us reverse. Velocity is given. You are finding gamma. Sir, small questions వస్తాయండి, ప్రాబ్లమ్స్. మరి అసలు ప్రాబ్లమ్స్ రావనుకోవద్దు. స్మాల్ థింగ్స్ వస్తాయి. కేర్ఫుల్. వెలాసిటీ. నౌ లెట్ us say velocity is equal to చెప్పండి 3 by 5. Okay, 3 by 5 C. Again you have to take a right angle triangle. This time velocity given. Sir, velocity denominator hypotenuse. This numerator side. Sir, gamma numerator. This one. Cool. So velocity hypotenuse. Other one. Here. Now we are finding gamma numerator. You should write other side, not earlier given one, other one. Is that clear? Right down. మీరు ఫైండ్ అవుట్ చేయండి. వెలాసిటీ ఈజ్ గివెన్, ఫైండ్ గామా. స్పెషల్ థియరీ ఆఫ్ రిలేటివిటీ అండి. మాస్టరు గామా hypotenuse by side. Masteru, velocity side by hypotenuse. Don't forget this. Please write here. Now 5-10 minutes you will remember, but please write there. Gamma hypotenuse by side. Velocity side by hypotenuse into C. By using this small Pythagoras theorem, we need not to do that mathematics. First two questions, velocity given, find gamma, and gamma given, find velocity. When velocity given, please remember side by hypotenuse, side by hypotenuse. Sir, side is not C, it's 1. Do it yourself. In one interview, somebody asked, I think Bruce Lee, someone asked, you are not having fear, why you don't have fear? You are not having fear about anything, anyone, so why you are not having fear? He said, no, I have fear, but if a person came who practiced 10,000 times, then definitely I will get fear. Not understand. He also didn't practice that. If someone came, practiced more than me, definitely I will get a fear. So what if
give gamma is for like 0.2,
0.5 ఇచ్చిన 5 by 10 కాకపోతే అది లెస్ దాన్ 1 కదా. గామా అనేది ఎప్పుడు గ్రేటర్ దాన్ 1 ఉండాలి, లెస్ దాన్ 1 అనకూడదు. అందుకే ప్రాక్టీస్ చేయండి, దెన్ ఓన్లీ విల్ రిమెంబర్. మా లక్ష్మీ, ప్రసన్న, పద్మజ, చిలుకూరి, మీరు కెమెరాస్ ప్రాపర్గా అరేంజ్ చేసుకోవాలి. కెమెరాస్ ఆర్ నాట్ వర్కింగ్. టుమారో వీ వోంట్ గివ్ ద యాక్సెస్. ద లాస్ట్ వార్నింగ్, లక్ష్మీ, ప్రసన్న, పద్మజ, సిహెచ్, కెమెరా లేకపోతే అటెండ్ అవ్వద్దు. ప్లీజ్ డూ ఇట్. ఆన్సర్ చేయాలి సార్, ఆన్సర్ చెప్పాలి నాకు ఇప్పుడు. రైజ్ ద హ్యాండ్. ఇఫ్ యూ హ్యావ్ డన్ ద ఫస్ట్ క్వశ్చన్, ఫోర్త్ క్వశ్చన్, ప్లీజ్ రైజ్ ద హ్యాండ్. ఫర్ ఈచ్ ఆన్సర్ 10 rupees విల్ బి డిపాజిటెడ్ ఇన్ యువర్ అకౌంట్. ఓకే, ఫస్ట్ వన్ చెప్తాను. స్టిల్ ఇఫ్ ఎనీబడి డిడ్ంట్ అండర్స్టాండ్, షల్ ఐ ఎక్స్ప్లెయిన్ ద ఫోర్త్ వన్? రూట్ 2. గుడ్. మామి ఇంకా స్టిల్ ఇఫ్ ఎనీబడి డిడ్ంట్ అండర్స్టాండ్, సి వెలాసిటీ ఈక్వల్ టు 1/√2c అండి. సో వెలాసిటీ న్యూమరేటర్ సైడ్, డినామినేటర్ hypotenuse. Don't write, see the board. Next one you have to do hypotenuse √2, side 1. So this is under root 2 square 2. 2 minus 1 1. Okay, finally 1. That's it. Gamma equal to first hypotenuse by other side of course 1 only. Answer √2. Now do the fifth one fast. 2 by √3. 2 by √3, yeah? Don't get fear by seeing the task. No task is difficult. Answer 2 by √3. Good, very good. Come on, online. At least one student say the answer. అమ్మ సరస్వతి జీ, మీరు కెమెరాను ప్రాపర్గా సెట్ చేసుకోండి. నేను మరలా చెప్పనమ్మా. రాజశేఖర్ గారు చెప్పండి అండి. జీ రాజశేఖర్ ఆన్సర్. మీరు చెప్పండి సార్. ఆన్సర్ రాజశేఖర్. అట్లీస్ట్ ఆన్సర్ వన్ క్వశ్చన్, యూ విల్ గెట్ కాన్ఫిడెన్స్. మీరు ఏమి చేయకుండా కూర్చుంటే మీ మనీ వేస్ట్ అండి. హనుమంతరావు గారు చెప్పాలి. మీరు ఇది లేదు మన ఎస్ హనుమంతరావు గారు. 2/√3. వెరీ గుడ్. 24/√7. 24/7. ఓకే. √24/7 అండి. 6/10. గుడ్. వెరీ గుడ్ అండి. సార్ స్మాల్ థింగ్, పైథాగరస్ థీరం స్కూల్ స్టూడెంట్స్ ఆల్సో విల్ డూ. మీరు చేయాలి. ఎవ్రీబడి మస్ట్ డూ. దీని ఆన్సర్ ఎంతండి? రూట్ ఇది 2/√3. This one √24/7 C. 3/? That's good. అయ్యా టీహెచ్ స్వాస్తిక్ చేశారా? ఆన్సర్ వచ్చినాయా? ఓకే. అయ్యా మల్లేశం మల్లేశం బాబు చేశారా బాబు? ఓకే రైట్.